So now, I think if this is the xy coordinate plane, here's my z-axis. My line of intersection is not going to pass through the xy coordinate plane, therefore z cannot, is not going to be equal to 0 as long as the line of intersection is running parallel to the xy coordinate plane. But it's certainly not the case because I've got 3 components that are non-zero.
So to not pass through the z-axis, it would have to be...
Well, I'm talking about passing through the xy coordinate plane,
Right.
because that would give me a z value of 0. And I know it does cross the xy coordinate plane because its components are non-zero.
What if they weren't flat planes? What if they were like curved?
Oh, you got to give me a few more minutes for this.
So you're saying there is some point where z would be 0.
Yes.
It's on the axis.
And that's why I had to write and say, oh, I just make up a number out of thin air for z, or whatever, x for y variant doesn't make any difference.
So basically, if one of the components of the vector is 0, don't set that one to...
Right, analyze what that really means, graphically speaking. Just analyze it. Have I said enough about planes, you guys? Let me think. Okay, I can live with it.
Is that a z?
Yes, it is. Do you guys agree that with what I'm writing on the whiteboard, this kind of looks like I got z being equal to some function in 2 variables? Matter of fact, I think in particular f is a function in 2 variables. And I think we could talk about its graph. You guys are going to have to start thinking about what this picture looks like in 3-dimensional space by putting some things together. Here's the x, y, z coordinate system. Any thoughts? Yes, sir.
Well, what happens when we just let y equal 0?
Then I think if y is equal to 0, we're living in the xz coordinate plane.
Yeah.
And I think how this surface intersects the xz coordinate plane, if y is equal to 0, is just simply like y equals 1 over x squared, but with a z-axis. And so, what does that look like?
Like I was below that instead of being flipped, or it's just, yeah, exactly like that.
And this is on the other side of the import.
Yeah.
But what if x equals 0?
And it's the other way
Oh,
around.
same thing. I guess I get this curve in the yz coordinate plane, or I can say this is the corresponding trace of the surface in the yz coordinate plane. Looks something like this. Oh, but wait. Let's do something else. What if z is equal to 1, 2, 3, 4, 5, or 6? What's that equation look like in Math D?
Circle.
I agree. And so I think I'm getting cross-sectional slices parallel to the xy coordinate plane that are nothing more than circles. And so I think the surface is going to consist of a bunch of circles like that. It's just it's got a spout. It's getting taller and taller, asymptotically along the z-axis. And you guys, I'm just a volcano. I'm making this example about a thinner. I'm just trying to piece together what it should look like. What do you think this one should look like? Can anybody just panic and say something?
Is u dependent on both?
Man, you said something about zeros.
Well, x and y is 0, z is 0, so that's 2 points right there, right?
It's 2 what? It's 2.
Intercepts.
It's 2.
Points?
I think lines.
Lines?
Because I think if x is equal to 0, that means z is going to be equal to 0, and y could be anything. So I'm suggesting the surface has to necessarily cross the y-axis. But it also crosses the x-axis using the same logic. Now, imagine the intersection of this wall and the floor is the y-axis. The intersection of this wall and the floor is the x-axis. And the intersection of these 2 walls is z-axis. What happens in the xy coordinate plane if I just walk out in the first quadrant? More and more and
Z
more.
increases.
Well, I think x and y are going to increase. And so z is going to correspondingly increase as well.
So it's going to come like this. It's kind of
Yeah, I think it's going to be a sheet coming up in the first octave. What if this is the xy coordinate plane and I walk behind the wall in that direction?
It's going to be another sheet coming up.
No,
The one will go down
Oh.
because my x values are negative. Maybe this is an example that's difficult for me to sketch by hand. Maybe here's an example where I should be turning on my technology. In doing just that, oi. Oh, you guys, I don't even know what we have on this computer. WinPlot should work.
Yeah, download this.
That's weird.
And with my arrow keys, I can rotate it.
Oh god, that's hideous. It looks like, it looks kinda like the Starfleet logo.
Yeah, it does.
The start.
If you make it horribly.
Yeah, if you make it so it's kind of flat.
And I can put the axes in.
Rotate it a
So if
little
you guys
bit
need
more.
to print this off, now you can do it on take home quiz.
What?
So if I assign something like this on take home quiz, you can now print it off. You just right click. Oops.
So do we have that for
Yeah, do we?
What's that?
We don't have
You could just download it, right? I mean, it's probably free.
What?
Copy to clipboard. Now when I said, now when I open up this Word document,
So is WinPlot, is it free online for download?
I have no idea. I'm sure it's not, but you have it in the math section, right?
And then just copy it to a Word.
So we could just go into the math center and copy it onto a flash drive and
Oh, I don't
steal
know if
it?
that's legal. I'm just saying. You got
Okay.
it. Why?
Or we could just come to your computer there after
Put it on
class.
Google Drive. The upper Google Drive, you don't need anything.
So I can bring
Yeah.
it back in my Word document. Nifty business. I assume you guys understand that the TI-89 graphic calculator is the same thing. This one here, the virtual TI.
Can you actually like print images off of that though?
It is not.
Yeah, it is.
It says
It is now TI-89. So you guys can change it using 89 as well. So I come in and I can access my equation editor, and I can type in something like, how about an x squared plus a y squared? And graph the darn beast. What do you think it's going to look like?
It looks like error.
Uh-oh.
We were doing,
What did I do?
You angered the TI-89 gods.
we had y and x.
My apologies. My goodness.
Yeah.
Go to my mode, change from function mode to 3D mode. My goodness. Enter. Enter again. Now when I go into my equation editor, I can write z as x squared. Lose my voice, jeez. Plus y squared.
You getting sick on us?
I think so. Now when I graph the surface. Okay, so it really needs a thing. It's got quite a few points to compute. This is so good.
Very slow.
Wow.
I have to rotate it.
What is that thing?
You can't see it because, let me zoom in a little bit. Can I do that real quick? Zoom in.
That's really nice.
Yeah.
Maybe we could just do that in WinPlot.
Yeah, let's do it when. WinPlot, what is it? Expert. Yeah.
It shows it better.
Oh, it does a much better job. That's actually why I wanted to graph it with the TI graphic calculator, so you can understand that the TI graphic calculator does a very cool job, I think, with 3D.
What about the Inspires? Did you use one of those?
I got one. I don't know if I does 3D.
So I know there's like color ones too.
So,
Why am I hidden?
Well, it was already graphed, and then you pressed graph again, and it said hidden afterwards, so just press graph again, maybe.
Did I do it twice?
No, it's right there, you're good.
If I did, Dr. Ross. everybody. I think this graph is a little bit different. It's what I'll refer to as a paraboloid.
Is it gonna be solid going up?
No, it's not solid, it's completely uneven. In fact, you
No,
can
I mean, on the sides, will, do we have?
Yes, it's just because with the restriction of the domain in the XY coordinate plane, it cut it off.
Yeah, in terms of
Okay.
But it goes on definitely in that direction.
Okay,
So
so
if
it'll
you
be the surface are solid all the way around, all the way up.
Well, this example is.
Yes.
This example
Yeah,
is.
on this.
And I refer to this as a paraboloid in three space. It's a three-dimensional analogy of a parabola.
What would a cross-section of it in the XY plane look like?
You mean parallel to the XY coordinate?
Yeah.
A circle. It has to. Just check out the equation. Did you guys see how I typed it in? It was z being equal to x squared plus y squared. Do this. It allows z to be 5. That means that a cross-section of slice parallel to the xy coordinate plane, where z is equal to 5, what's the intersection going to look like?
So I have a bunch of intersections.
Well, not when z is equal to 5. Specifically, it'll be a circle, where the circle whose center is at the origin, radius root 5.
Oh, that's what you meant. I thought
No.
you were saying like how many points could X and Y have? I'll be like, they could have like infinite.
Why don't you look at the traces parallel to the xz coordinate plane when y is constant? What would that look like?
Z equals X squared.
Parabola, which is exactly what I have. Parabola is getting higher and higher as the y values get higher and higher. It's just a vertical shift. Why is that? It's not. The
just can't go
technology's not graphing all the points. They cut it off. And so you see the spikes. What would this look like?
How about we graph it and find out?
Well, I will. But what do you think it should look like? I'm just trying to make something.
Oh, z will go from 0 to 1 as X and Y go to infinity.
Okay, be more careful with your.
I mean,
Maybe
negative
like
1 to 1.
this,
That's
so like
Very
spreading out in all
nice.
directions.
Emanating from the origin, I'm going to
Kind of
behave
a washboard.
sinusoidally. It'd be like waves. Let's see if I'm right.
Like ripples in a pond, maybe?
Yes.
That would be interesting.
You have to click it? No, click the graph.
Yeah,
No,
click
no,
my
not
box.
that graph.
Inside of my
Z.
box.
Yeah, there you go. And then click edit.
Edit down, top left.
Yeah, I just don't use this often.
But,
Old people.
you know what, I'm actually starting to be of the opinion that, you know, that as the generations go on using computers more and more, younger and younger, it's gonna become more prevalent than English. Computer literacy.
I've heard that like we're like technology natives and that we've grown up with it, so our thinking is inherent in how technology works.
Yes.
And so
Oh,
we
I
can
agree.
figure stuff out like a lot
Oh,
faster.
I agree completely, yeah.
Definitely.
So Windows is kind of becoming the universal language. That looks pretty interesting.
It's kind of like a four-legged, I don't know.
Well, that's just
spider
because,
bomb.
that's just because, that's just because you're looking at it chopped off
Apple.
out to a certain.
Tadpole?
Yeah.
Pond ripple, really big.
Okay, that's actually like a way more realistic version of what it is, but.
A
Yikes.
very exaggerated one. I suppose if you put some constants in there to make it look more like there is in a pond where it's very small.
Yeah, I can do that.
Oh my god.
You guys, what example am I on?
So, do you,
Like
Technically, you should be on 7.
do you know the equation for graphing a Mobius strip?
What's that?
Do you know like the equation for graphing a Mobius strip?
No, but I've come across it even recently.
Okay.
You come across it what?
Even recently.
Is
It
it
might be in
Googleable?
DP graph.
Huh?
It might be in DP graph.
DP graph? Okay.
Check that math center.
Is this something we're going to be able to graph by hand?
Yes. Well, I want you to know what it looks like, period.
Wait,
What do you think?
graph this by hand?
No, not, no, it's just me.
No, hold
okay,
on.
I was gonna say,
This
you,
thing-
you think very highly of my skill. You think graph that by hand.
This looks like, I know I've seen this before. This looks like,
Almost like an ellipse.
Close.
Ellipsoid,
In a Z, is, a what?
ellipsoid,
Say it again.
ellipsoid,
Say it one more time.
ellipsoid.
I still can't hear you.
Ellipsoid, it'd be like.
Really?
Maybe,
I think it's a paraboloid.
or paraboloid.
oh, it's just with some constants in
X-axis, Y-axis, Z-axis. In fact, I'll even subclassify it as an elliptical paraboloid.
Oh, I see. It's where the cross-section parallel to the XY plane is shaped like an ellipse rather than like a
Yeah,
circle.
I agree. So cross-sectional slice parallel to XY coordinate plane is going to be an ellipse.
What's going to start out?
What's that?
Because it's going to be stretched along one of the axes, right?
What you mean by that?
like, because the cross sections are gonna be ellipse, so it's not gonna be symmetrical along the X slice than the Y slice.
I think there's symmetry, a lot of symmetry in the picture. With
Yeah,
respect to
but
the
like-
XZ coordinate plane, the YZ coordinate plane, symmetry is relative to the Z axis.
No, I know there's symmetry, but like along the XZ, a slice there would show a certain parabola that would be
Yes,
narrower than.
I see, yeah, it depends on what the AB values are, yes.
What would be the equation of ellipse, I mean, a cylinder that's ellipse shaped?
As soon as
So
ellipse,
everything's parallel.
There's no Z.
So you're coming down into a bowl, just as an ellipse that goes straight up and down.
Kinda does, you're right.
I'm sorry, it's so slow, just a minute.
Like this.
No, I'm thinking of an example. Here it is. It's all,
Infinity.
yeah, because look at what it's like in
Okay.
three, in the XY coordinate plane, it's just ellipse, but now since Z wasn't given, you're just gonna slide
Okay,
it on
because
the
that's what I
axis.
thought it would look like when I saw the equation originally, so.
You wanna graph this for us on this fancy website?
Which one, the paraboloid?
Yeah.
My impression.
Is that one called like a cylindroid, or is it just a cylinder? I mean, you like to add oid to all these.
It's the invasion of the old.
What's that?
The shape ones. That would be a good name for a second.
Oh, yeah.
I saw this, I thought it would look like.
Identify the shape weights.
But I think that can't be because Z can never.
Also, we don't want that, we want z equals x squared over a squared.
Right?
Okay, so this is the same thing we had before.
It put a Z in.
But in this situation, Z can be anything, yeah.
Maybe we should look straight down at it from a point.
Look straight down.
Yeah, from a point.
No,
on.
it put a Z in automatically.
Whoa, looks like a box.
See your satellite dish? Gotta get the idea.
Uh-huh.
What was the name of this shape again?
Parabola.
This is a parabola, three-dimensional parabola.
These have the same
How do you get the
properties
ellipsoid?
as parabolas that would, bounce
All right,
sideways
now
or
change that
just
to
add some
Z equals
constant.
1.
Absolutely, yes, absolutely, yes.
Like, Valaga, could you add like a constant on these x squared over 3 or something like that
Yes.
to give an example of an ellipsoid? Or, sorry, a paraboloid that happens to also be an ellipse at the same time.
Yeah, but it has to have like the curve.
Linda,
Exactly.
I cannot answer your question without going into, I think, implicit mode.
Okay.
I'm pretty sure, I haven't done this, so let's just figure it out.
We're in implicit mode now for some reason.
Because she wanted to graph with the cylinder.
You got it. Now it's hidden.
What am I doing wrong, seriously?
Well, it says x,
like
x
two
plus
X's.
y, y.
Well, it's
That's
square.
gotta be incorrect.
Cylinder, if you go to cylindrical, there's a specific cylindrical.
Is there really, Alex?
You go to equations.
The equation of cylinder. Gosh,
Maybe.
gotcha. No, that's,
Yeah, Z equals.
This is how I feel when I program Java.
Why isn't it, where did it go on the side? Hold on, sorry.
What?
You're not gonna go on the side, hold on, sorry.
Can it do infinite stuff?
what do you mean infinite?
Like, because if you graphed it, it would go boom and be this big column.
Oh,
right?
no, it just cuts it off, It's just like a graphic
Oh,
calculator.
it's like the other ones.
Yes, it's gonna cut it off.
Oh, well.
How about this one? Can you visualize yikes 5 minutes? Man.
Oh, no, you have like 9 minutes or, no, 7 minutes. Come on, let's see you explain theoretical physics in 7 minutes.
A hyperboloid?
What's that?
A hyperboloid? If there is such a thing?
Hyperbolic parabola.
Hyperbolic parabola?
It's a hyperbolic parabola because if I allow y or x to be 0, I got parabolas. But if I got z equals 1, 2, 3, 4, 5 are negatives, cross-sectional slices are going to be hyperbolas parallel to the xy coordinate plane. And I think graphically speaking, it has to be in the shape that I talked about with the universe.
So the universe is the shape of a hyperboloid.
Can you guys appreciate how if x is equal to 0, the cross-sectional slice is just as parabola? But if x is equal to 0, that's what I should get. C equals y squared is a parabola. Cross-sectional slice when z is like a constant like 5, putting a 5 in for z, doesn't that just give you a hyperbola? If z is negative 5, still another hyperbola, but it's rotated 90 degrees.
Oh, that's what you're looking from the top of the hyperbole.
Yeah, I agree.
So, that goes on like forever, but
Yes.
it's only expanding in that shape,
Yes.
so,
Some people call it a saddle. It's a lousy word for it.
so if that's our universe, we could be like,
No, when I said shape of the universe, I'm only saying that when I read the news 1 or 2 weeks ago, a science project did proclaim that the data echoing of the Big Bang is behaving in this fashion in terms of the
so
echoes.
the Big Bang is right,
Oh, I have no idea.
would be potentially.
But this is the shape of the universe, so I would imagine that's true, but I don't know that.
Unless, of course, something's messing with our data.
Well, that could always be the case. That's why whenever I hear these things about the shape of the universe, it lasts for maybe 5 years and no changes. Because further data suggests that it wasn't quite accurate.
Why do we really care about the shape of the
I don't care about
universe?
anything.
I think knowing the shape of anything gives you such rich geometric information. I think it's very important.
But how is it useful? How can we apply it now or?
Traveling through it.
Well, yeah, put it this way. If the universe were shaped like this, doesn't it give great meaning to wormholes?
Yeah.
Because now I can connect the point directly to this point by jumping out of our universe into a higher dimension. I think there's a huge consequence in knowing the shape of the universe.
Does that bottom part go infinitely down?
Yes, this is bending down like this. You know it does because when I allow the z values to be negative, I get a bunch of hyperbolas.
So there's no end at the bottom, it just keeps.
Correct, it goes down.
Alright.
Oh, I had a comment, but there's actually very little time, so.
Yeah, you guys, what are you thinking to do next? I'm gonna do something different tonight. I think for the homework. I'm gonna have you guys come in and look at the rest of the curves that I want you to look at. I said curves, I meant the rest of the shapes I want you to look at. Yeah.
Now, this is going to be. So what is it again?
I want you guys to take a peek at this.
Is that a thing we should memorize
I didn't say memorize, I don't memorize anything.
or recommend that we should know for a test?
Table 12.
We don't need to know them.
Okay.
I want you to know the equations of standard shapes like ellipsoids, elliptical paraboloids. Hyperboloids of one sheet as opposed to hyperboloids of 2 sheets, which makes a lot of sense, because if z is equal to 0, that statement is meaningful in mathematics, you get a circle, and I do get a circle as I look at a trace in the xy coordinate. I think here with this equation, I should get a 2-sheet hyperboloid, because when z is equal to 0, there should be no point, and look, when z is equal to 0, I get negative something squared, most negative squared equals 1, that's not even viable, mathematically speaking. So I think the shapes are immediate consequences of looking at these equations. And look at the traces to cross-sectional slices with the coordinate planes.
You just want us to look at these standard equations?
I want you to know them.
Okay.
And notice how I've got the darn hyperboloid. Excuse me, I misspelled. Hyperbolic paraboloid that I'm trying to draw on the photo there. It's just that the author does a better job than I